In this video we're going to look at this problem, which is an example of how sometimes the most confusing thing about equivalent resistances is actually how the circuit is drawn. You'll find all sorts of different rules for sort of filtering through the graphics portion of this, and I would encourage, if you think this will help, do a quick Google search. You can find lots of stuff. I just like to think about how the current is flowing. So as I look at this, it's obvious that there's some parallel components to this, and it's obvious that there are some series components to this. And so what I'm going to try to do is just pare them down one by one. The easiest thing I can see is that, and where I'm going to start, is that these two resistors are in series. And let's see what it would look like if I changed this circuit for an equivalent circuit with these two resistors as an equivalent resistance. So the first thing to do is calculate the equivalent resistance. These are in series. Equivalent resistances for series circuits is just a summation of the individual components. So in this case, that's R equivalent is equal to 1 kilo ohm plus 1 kilo ohm, which I can do in my head, 2 kilo ohms. So now when I redraw this circuit, it will look like this. This is probably going to get ugly because I'm drawing with my finger on an iPad. And I will put it here. So I'm going to leave off the units just for clarity's sake. I would never encourage anyone to do that, but I'm going to do it for now. And this is my equivalent resistor. So what I've done here, if you missed this resistor is equivalent to the resistance of this series combination right there. From the perspective of a battery, what the battery sees is this 2 kilo ohm resistor. So now I can see something else happening. I can see that this is a parallel combination. I'm not going to be able to put it in parallel with the other 2 kilo ohm resistor yet because I've got this that throws a monkey wrench into those plans. And so the best I can do right now is just to say, okay, I've got these two 2 kilo ohm resistors in parallel, and I can form the equivalent resistance of those and draw yet another equivalent circuit. So for parallel, hopefully you know this. This is, if you don't, there are other videos that you can watch to show you that. The inverse of the equivalent resistance is equal to 1 over 2 kilo ohms plus 1 over 2 kilo ohms. Again, I'm going to leave off the units for the sake of clarity. And what I get is that 1 over R equivalent is equal to just 1, right? 1/2 plus 1/2 just equals 1. So when I take the inverse of 1, then, to get my equivalent resistance, I just get 1, because the inverse of 1 is 1. And so these, let me circle it again, this parallel combination of two 2 kilo ohm resistors in my next circuit drawing is going to be replaced by just one 1 kilo ohm resistor. Let me go to a different page to do that. So I'll have this situation. And I forgot what I'm doing here. Yep. So here's my 1 kilo ohm, here's a 1 kilo ohm, here's a 2 kilo ohm, and I'll circle it in a different color. This is my equivalent resistance, which I just found to be 1 kilo ohm. Again, I'm leaving off the units. When you're writing this on a piece of paper, please don't do that. Keep your units in. Always keep your units in. I'm breaking the cardinal rule of physics here just because it's difficult to draw. It's difficult to write legibly on this screen. But keep your units in when you're working this out. Alright, so now I have a situation very similar to the one with which I began. I've got a series here of two 1 kilo ohm resistors, and so I'm going to sum that up. And I think I can skip the math for that. It's just the equivalent resistance is 2 kilo ohms. Here, I'll put in the units there. So I'm going to draw another circuit that looks like this. Here's my 1 kilo ohm, 2 kilo ohms, and here's my equivalent resistor. This is my 2 kilo ohm resistor. So again, I have a parallel configuration with two 2 kilo ohm resistors. I've already done that work. I can tell you that the equivalent resistance for that is just 1 kilo ohm, right? That's the problem I just worked out. So this is an interesting problem, and it's because the numbers are like they are. I've already done the math for most of these problems. Now if you have a situation in which the setup is the same but the numbers are different, obviously that's going to work a little bit differently. But for this one I've already done the math, and so I can again draw an equivalent circuit which looks like this. Here's my 1 kilo ohm, and now I have my equivalent 1 kilo ohm. Here I have room to put in the units here, I'll do it. This is my equivalent resistor. This is my 1 kilo ohm resistor. And now of course I'm at the last step. I've got two 1 kilo ohm resistors in series, which means that my equivalent resistance, again I just add them up, 2 kilo ohms, which means I can redraw my circuit finally like this. So all that to say, wrong, 2 kilo ohms, right? Equivalent resistance is 2 kilo ohms. So I redraw my circuit with a 2 kilo ohm resistor. So let's go backwards. That 2 kilo ohms comes from the equivalent resistance of this circuit. What is in red here, the 1 kilo ohm resistor, came from the equivalent resistance of, circle this one in red too, this one. That one came from the equivalent resistance of this one in red. That one came from the equivalent resistance of this one in red, which came from the equivalent resistance of this in black. So the whole equivalent resistance of this circuit is just 2 kilo ohms. So if I were you, I would encourage you to create a similar problem, but put in different numbers. In other words, don't make it so pretty, right? Make it something where you're going to have to wrestle with the fractions and just practice going through it. Who knows if you get the right answer? Just double check yourself, and if you get the same answer a couple times, you can probably be pretty confident about that. Or come talk to me and I can guide you through it. Okay, hope this makes sense.